Hi, my name is Laurence Pitt, Security Strategy Director here at Juniper Networks, and conversation today is businesses are looking at IoT as a move forward, but I think we need to be putting much more consideration around security when IoT is being looked at. I'm going to start with a couple of stories, and as I've travelled around and talked to people, everybody has a different story about IoT. Some of them are funny, some of them are not so funny. These, I think, are a couple of really interesting topics which a couple of businesses have done around the world, and they're different use cases for IoT, but they really can help us to think about how we need to be protecting information and also what people can do when they think outside of the box. So the image we've got here on the left, the towels. Why that? Well, this is a hotel in America, and this hotel chain in America, actually, a small boutique chain. What they've done is they've actually connected all of their towels and their bed linen and everything that moves around, and they've made it IoT. They've made it so that they know where it is at any point. Now you'd think, well, why would you do that? It's going to be quite expensive and not really sure what the point is to that. Well, there is a really good point. This is a resort hotel. They have saunas, they've got swimming pools, they've got a beach nearby, they've got people in the bedrooms. So if I've got a towel and I use that towel in the shower, then it doesn't need to have a 100-degree wash to clean it afterwards. If I take that towel to the beach, it's going to be full of sand when it gets cleaned. If I use it in the swimming pool, it's going to have chlorinated swimming pool water on it. So it needs a different type of wash to clean it. So by being able to track where things go, the hotel is able to say, okay, well, these towels need to have a 30-degree wash, these towels need a 60-degree wash. So they're actually saving money on how they clean and how they cycle the things they've got and knowing where they are. The same goes for bed linen. They know how long bed linen's been in use and where it's been as well. So it helps them to save money on that. So this is a really good use case because it's letting this hotel chain save money on what they're doing by connecting something you would not usually even have thought about connecting. So now we move to the toilet conversation. I have to bring it down to toilets at some point. This is actually in relation to concerts. Everybody loves the thought of having to use the toilet when they go to a rock concert. It's everybody's favourite part of a rock concert is working up to that point where you know that there's no choice and you're just going to have to use the toilet. Why is that? It's because it's not generally a very pleasant experience. And this company, actually in Denmark, they realised that people didn't like using the toilets. Simple, really. What they then realised was that they could connect the toilets up, and by tracking the toilets, they could make that experience a better experience, but they could also make it more efficient for them as well. They have a weight sensor in each toilet. The weight sensor knows when the toilet is full, when the toilet's empty. So that means they know when they need to go and clean it. That's a simple one. It also gets more complicated. They also know if there's a rack of 10 toilets, and one of those toilets is recording as empty all of the time, and the other ones are getting full, there must be a problem with one of the toilets. They need to go and have a look at it. They know if they've got 2 racks of toilets and some of them are getting full and needing to be emptied a lot and the other ones aren't, then the other ones must be in the wrong place and that they should move them. So they can be more efficient on the positioning of the toilets, the cleaning of the toilets, and knowing if they've got a problem to deal with. So instead of having to have people go out to every single site all of the time and clean things and work on things, they can target their engineers where they need to go, what they need to do, and how they clean things. So again, it's more efficient use. But all of these are collecting data, lots and lots of data. And these amounts of data need to be managed, they need to be secured, and they need to be understood by the business. And that's the conversation that we're going to be having moving forward here, because things are changing. Things are changing a lot. Applications are moving from being on-premise with data on-premise into the cloud and up into multi-cloud as well. I mean, this is, last year we were talking everything was hybrid cloud. I've got servers and I've got some stuff in the cloud. And now there's a realization that actually I've got multiple clouds that I'm using. I may have 9 or 10 or 15 different cloud providers that I'm using to store my applications, to run my applications and my data. And all of that needs to be secured. The perimeter of the network is shifting, and we'll talk about this quite a lot more during the presentation because of the way that people want to work and the way that people want to do things and the globalization of business. And so the perimeter of the network itself is actually shifting out and becoming more elastic in how people need to do business today. Traffic is highly encrypted, so it's very rare to just see plain traffic moving around. because the traffic's encrypted, then it's down to the business to know what that traffic is and what it's doing, because not anybody can get in and look at it, but they still want to be efficient in how they're moving it around, making sure it's going across the fastest network and it's got the lowest latencies to be able to do what they need to do. And then finally, the growth in IoT. And everybody is just so aware of how much IoT there is out there, but there is an exponential growth here. IoT devices create vastly more data than people do today. And that's something that we really, really seriously need to think about moving forward as well. Because the opportunity around IoT is absolutely huge. We take a look here at some of the numbers. Every single one of these numbers is sitting in the multiple billions. The number of devices themselves is sitting in the multiple tens of billions within a very short amount of time. People want to have IoT in their office to make how they do business more efficient. They expect IoT on industrial control systems to make how they make things more efficient, to track the information that's coming out of them. Some things we connect are sensible to connect, is something that we want, is something that we know can be connected up and it will work well as an IoT device, a phone for example. Other things, maybe not so. Industrial control systems which may have been in place for 15 or 20 years because they have a very long life cycle, but the businesses are connecting them because they can see the benefits of pulling data from these devices and using that data to make their manufacturing processes more efficient. But that device was never planned to be connected in any way in the first place. And so there's very, very big security considerations that need to be put in place when you're connecting these type of systems to the internet or to network connected systems. When we look at it, really how we connect and what needs to be considered comes down to a number of common areas. We need things to be fast. People expect high performance from their IoT devices. We need scale. They want to be able to roll out lots and lots of these devices in different places. There has to be low latency on how they're using them. I mean, if we take the connected car as being a use case here, for example, if you had the difference between thousandths and millionths of a second in a reaction to something, would you really want to have a 0.2 of a second break between put foot on brake and car stop? That's not going to work so well in an accident situation, is it? We need that to happen instantly. So low latency is actually critical, but when you're doing that at scale, that means you've got to manage the network and understand the data flows that are going across the network as well. And then finally, of course, it needs to be highly secure, not just because of people protecting their own competitive advantage and their own information, but also because of the information that's being protected provides an opportunity for people to be able to take control of that and do things that might not be so good to business. So look at the areas around here again. Each of these areas, although we've got these 4 common spaces that everybody needs, that doesn't mean everything needs all 4 of them. The connected home, for example, I'm sure most of us, we have a connected home in some way. We will have something in our house. Maybe it's a thermostat, maybe it's an Amazon Echo device, maybe it's just your mobile phones on your Wi-Fi. That still gives you a form of a connected home. Security is very, very important for the connected home. Security in a way that the person configuring this doesn't need to necessarily be a part of that conversation, because we can't expect everybody in a house to also be a cybersecurity expert. That has to come down to the manufacturer. Connected car, as I've just said, latency is critical with connected cars as well as security. The amount of time between you doing something in the car or another car understanding that you're in its way has to be as fast as possible. Otherwise, there's the risk that absolutely everything could go wrong. Move down to something like healthcare, where security is very, very important. Scale is very, very important. Performance is very, very important. So that you see there's different things that are important for different organizations and different types of business. And although we have the common areas to consider, when you verticalize this, you will need to think about different of those common areas to make it work for different businesses. And then the business model itself that sits around IoT as well. I mean, it wasn't so long ago that the chip that causes the difference between a dumb device and an internet connected device might have cost $5 or $6 to put in place. And so these were relatively expensive. They weren't going to scale to hundreds of thousands or millions of devices very, very easily, because the cost impact of doing that was going to be massive. Well, that's changed. And we're seeing these things dropping down. I mean, 50 cents here on the slide. I've seen stories of IoT chips that have been under 10 cents. So these things are so cheap. It pretty much means you could connect absolutely anything that you want to connect. You could have a connected jacket, connected shoes, connected watch, connected chair. Anything could be an Internet of Things device if you want to do it. But how do you embed security into that? Because if you've got a chip that only costs 5 cents in the first place, and yet adding a security layer to that is another 3 or 4 cents, actually that's a huge hit on the profit margins to do that. So this is something that needs to be thought about very seriously because of the number of devices that are doing this. I mean, today, I think a lot of the averages are saying there's around 7.5 billion connected devices out there. Well, mid-2020s, that is likely to grow, and I've seen estimates of anywhere between 40 and 70 billion, and I think those are probably on the light side anyway. It's very likely we'll see more than that, and that's going to grow into hundreds of billions and maybe even trillions by the time we get to the 2030s, because there are so many different types of devices that are being connected. As I said earlier, it could be anything from a jacket to a chair to something that we actually need to connect, but they can all be connected devices for whatever reason, really. Then the network that IoT sits on. I mean, today, the IoT network is the same network that your laptop sits on. It's the same network that you stream Netflix over. They're doing the same thing, but the requirements of IoT devices themselves are different. The IoT devices need fast networks. They need low latency networks. They need very scalable and agile networks to be able to cope with the exponential growth. I mean, I guess a great example would be that IoT Christmas present everybody got last year. We won't even say what it was, but that's going to scale from selling 1 to selling 1 million in a month. That's another 1 million devices that are connected to the IoT network, and all of those devices are going to affect the scale and the performance of that network. So these are all things that IoT has to consider, and we'll talk a little bit more about that later on in the presentation. Then, of course, these are no human devices. These are devices that are getting on and doing their job with limited or maybe even no interaction once they've been set up at all. They're just out there and they're doing their thing for as long as they need to do it. Think about something like, wind electricity farms, for example, where there may be millions and millions of sensors sitting in the middle of a desert waiting for wind to come up so they can start to be able to generate electricity. Well, you're not going to have a human who's going around looking at those every day to see what's happening. Those things have got to sit there for 5 or 10 years. And the only time there's an alert is when something goes wrong and they flag back that I've got a problem. And the devices themselves will last between 5 and 10 years to do that as well. They've got the batteries and the power to do that. So nobody is involved in that conversation. Which brings us to automation. Automation is absolutely key here. I mean, I couldn't ask one person to manage 1 million IoT sensors on a wind farm. I need to have an automated process so that I make a single change into my automation flow. That flow goes across the network, every single device picks it up, and it works. That's how this can succeed. That's how we can get that scale that's needed to work here. Because when it comes down to it, these devices aren't clever at all. In fact, they're dumb devices when it comes down to it. And this is an example that you've seen before. You've probably seen it from us before. I'm sure you've seen it on the internet, but it comes from techcrunch.com. And what happened was they took a car out and they parked the car in a car park, kind of in the middle of nowhere really, and then they turned it off. And this was a car that had self-driving technology built into the car. They then drew a solid line around the car, they drew a dotted line around the car. They turned it on and they said, right, go home. The car couldn't go home. The software had been programmed to know that if I see a solid line and a dotted line, I can't overtake because it's dangerous. If I can't overtake, I can't cross the line. The line's all the way around me, so I'm stuck. What do I do? So it just sat there, and I'm not saying it twitched, but it's a much better image if we think it sat there and twitched. So it would have just sat there doing absolutely nothing. Now, that was a fairly simple software fix to get beyond. That was something that would have been fixed and would have moved out. But it really proves to us that these are dumb devices. And if there were 1 million of those cars out there and this was discovered to be a problem, how do you get updates out to that? How much bandwidth is going to take to update 1 million cars so that they can address this problem? And what if it wasn't something funny like, I can't drive over a white line? What if it was actually something about drive-by-wire accelerator or drive-by-wire braking that was being updated? All of that needs to be considered, and that's something that we need to be aware of as much as the manufacturers need to be aware of that. Now, this brings us to the home, obviously, because when we get in our car, we're very often driving home. So this brings us to the home and thinking about security in the home. We all have connected devices. We all have a work laptop or a work phone. Now, if I'm using my laptop in the office, my laptop device is pretty secure. The organisation I work for, Juniper Networks, they really do have very, very good infrastructure for managing our laptops and things at home. They know what's installed, what's not installed. They keep things up to date for us, and it's all done silently. When I take my laptop home and I connect it to my home Wi-Fi, how do I know there isn't an IoT device on my home network which has been compromised and is looking for my laptop to be able to feed information to my laptop, understand who I am, and then use that as a targeted attack on the Juniper network? I mean, that is entirely possible. That could happen to any organisation today. This is why security is so important for home IoT, and not as an expectation on the individual buying the product to set up the security and configure the security, because a lot of people at home just are not capable of doing that. It has to be security that is embedded at the design point of this product, so that when you buy it and you switch it on, it's actually secure by design and secure by default on your home network. That's going to give you the best level of protection, so that you know that where you're working and what you're doing, your devices and your data remain safe around the home. So we talked a little bit earlier about the network as well, and the need for the network to be performant in order for IoT to be successful. And when we look at where the network is today, I mean, networks have evolved. You know, if I think back maybe only 5 years, where, I mean, 3G at that time I was seeing as being, you know, the future of everything. This was the best way to connect when I was out on the road. But today, how slow does 3G feel when you have to suffer it? When the 4G drops to 3G on your phone, it's like, oh no, the world's ended. And it's the same with things like Wi-Fi expectations. You know, Wi-Fi, we used to accept that was the slow way to connect. Now it's the fast way to connect. Everyone wants high performance broadband, high performance network. So the network's evolved. But even with this evolution, the amount of data that IoT is transmitting back to the network is vast. And so the manufacturers and the people doing this need to think about, what is that data? And does that data actually need to go where I'm sending it? Now, the use case I'm going to come on to has a little bit more about this in a minute, but just think about it. I mean, not all the data that you have actually needs to go anywhere on the network. There will be some useful information in there. Some of it will just be junk and it can be trashed, or it can be stored locally. Not all data has time to go to the cloud. Some data will need to be processed closer to the device, and then the processed information can be sent to the cloud. This again could come to the connected car example and the put my foot on the brake instant reaction. I haven't got time to wait for the cloud to process the fact I put my foot on the brake. What if the cloud wasn't there and I put my foot on the brake? Would the car not stop? So I can't really have that, can I? And then the bandwidth that's doing this as well is not always going to be available. Sometimes you may have the bandwidth to do something you may not. And I'm seeing more of this actually with intelligent solutions that understand, yes, it's okay, I can transmit all of that information now, or no, it's not, and I'm actually going to send what's important. I'm going to back off the rest and I'll send it at a later time. And then finally, there's how we want to work. I mean, everyone here, everyone who's watching this, the chances are at some point you work at home, you go to events, you work remotely. Any point you're doing that comes into this anytime, any place, always on mode of working that we have today. We all expect to just be able to pick up a phone, pick up a laptop, and get information instantly. And that puts a lot of overhead on infrastructure to make that happen successfully. So I'd like to go to a use case. I'm going to talk about the connected car as a use case, because we all like cars, and so it's a good conversation to have, really, isn't it? Connected cars is a huge growth. There's a lot happening. It's actually one of the fastest growing segments overall in IoT that we're seeing, as in a single use case segment. People like AT&T, Google, they're putting so much investment into the connected car and being embedded in the connected car. I mean, we all know, Siri, Google, Amazon, all of them want to have their voice in the car, because people command in the car, they learn what the commands are, they understand what people are doing, where people are going. All of that information is available to them for them to be able to use. It's estimated that there will be more than 10 million connected cars on the road just within the next couple of years. This is also being driven by legislation, because in the EU, for example, we have connected car legislation that's going in place. It's not specifically being used for things like sat-nav and music like you might think. It's actually being used for safety. It's being used so that in the case of an accident, a car can automatically report back, I've had an accident. This is where I am. This is my GPS location. Yes, the airbags have been deployed. The car is the wrong way up. All of this can go back, so the emergency services can be better targeted to go and sort a situation out. But manufacturers, being aware that this technology needs to be in a car, can also use that themselves. So if I take my phone out of my pocket and I go to the application for my car, I can unlock the doors, even though my car's 100 miles away at the moment. I could set the air conditioning to come on. In some cases, you can even pre-warm the engine on the car using an app on your phone with this technology. This is happening all over the world. The connected car is definitely an evolution that is something that is going to happen and affect all of us as we buy new cars. And the data that these cars transmit, well, is a lot. I mean, just a semi-autonomous car can create anything up to around 25 gigabytes of data per hour as it's driving. Now, not all of that data needs to go back to the cloud. As we said a couple of slides ago, some of that data is it's not going to be junk, but it's going to be information that's usable for the car at the time rather than anything that needs to be reported back. Perhaps 10% of that data actually will go back into the cloud. But even that 10% of data that's going back, we could still be talking about 2.5 gig of data being transmitted over the cloud in an hour. You know, think about where you live, think about the busiest highway or motorway around where you are, and the number of cars on that in the rush hour, in the morning or in the afternoon, and all of those trying to transmit 2.5 gigabytes of data uploaded back into the cloud to a manufacturer. And that's a huge amount of information that's being sent back, which needs the fastest network to do that, but also needs a huge amount of security around it. Because if somebody was able to get access to that, and they were able to use that data, maybe to say, motorway closed, let's redirect everybody through the city centre. Imagine the chaos that could cause. Imagine if somebody could ransom the closure of a motorway where there actually isn't a problem just by accessing this data that's available. So how can we secure this? How can we secure IoT and make things safer? Well, the first thing to think about is what needs to be secured. What is it that we actually need to do? Well, obviously endpoints are important here, and we're not just talking about the devices, we're not just thinking about laptops and phones here. When I talk endpoints, I'm also talking about the bigger devices, the switches and the routers and the firewalls, and all of these that also need to be secured with IoT or provide a part of that story. You need the data. You need the pieces on the network that provide you the intelligence to know what's happening. It's great if you've got all of these out there, but if they're not talking to each other, if you're not able to control those centrally so that if something happens, if a car does go rogue, I want to be able to get that car off the network instantaneously, work out what the problem is, and then bring it back on again. And so I need that level of control, and I can only get that with vast amounts of telemetry to do that. And then finally, I need the scale in the cloud to do this. Everything is in the cloud. So all my applications to do this will run from the cloud. My services will run in the cloud. Even the devices that we're talking about will be cloud-based devices as we move to the future. They need the agility and the performance of doing that. And then finally, all of this needs to be tied together with vast amounts of intelligence. Intelligence that you can glean from the devices that have been deployed, knowing who's connected to what switch, what traffic's coming through, which router, and what the firewall's doing. But also threat intelligence from multiple sources, knowing what's really going on out there, being able to take that in. And this is a two-way street. As much as you can benefit from threat intelligence that other people have created and know what's happening, if you see something, you can feed that back too. And then your threat intelligence goes back and everyone else benefits from something that you may have seen. So it keeps everybody safe. Here at Juniper, we have a number of solutions that can help and can assist and can get you to this point where you're protecting this information much more securely. Well, firstly, we'll talk about our next generation firewall, which is the SRX firewall. But in this case, I'm not talking specifically about the big ones, I'm talking about the containerized SRX. So this is being able to create a Docker-based firewall that will run alongside an application to protect that application. The moment that that application is spun up in the cloud, the firewall spins up alongside it and it keeps it safe. It's able to see traffic that's going in and out. It's able to do packet inspection on that device at speed and with agility. These applications may only spin up in the cloud for less than a second. You need the firewall to come up that fast, protect, and then they disappear, because the amount of time that something's running is a cost to the business. So we're going to see massive agility and massive speed on these things happening, which is where we need to be. And then protecting outside with the physical firewalls and the virtual firewalls, the bigger devices that can protect the entire network. And then Juniper Secure Analytics over all of this. So being able to leverage the intelligence that you're building up inside the network, building up inside these devices, and correlate that information with analytics that could recognize if there is an anomaly happening on your network, be able to say, okay, I don't like that behavior. There's something I need to do here, and deal with it. And bear in mind, I want to spot anomalies and not threats. Ideally, by the time I see a threat, something's happened, and actually I've got to deal with that situation. If I can spot something that's an anomaly, it might turn out to not be a problem. It could just be a rogue configured application or something that somebody didn't tell IT about, but it could also be something that's going to turn into a threat. So getting there as early as possible will drive benefit to the business. And then sitting more towards the edge of the network, SkyATP, so our advanced threat prevention solution, which is able to see traffic coming into the network and make decisions on whether to allow things in. This is how ransomware can be turned away, for example. Think about it. 3 types of traffic that you're dealing with today. There's the stuff you want to let in. You're going to green light. I know what this is and I'm happy with it. Let it in the network. I haven't got a problem with that. This is the stuff you're not going to let in. You're just going to turn it away immediately. You're not even going to process it. One look, I don't like the look of you, go away. But then there's a middle ground. There's the things I don't really know what that is, and I have to make a fast decision. This is what SkyATP can do. It can make that fast decision using sandboxing technologies, advanced detonation techniques, various antivirus techniques and tests to look at something and say, I don't know what this is, but I actually think it's good or I think it's bad, and I'm going to make a decision. And then it will say to you, this is the decision I've made. You then can allow it in or push it out. I mean, as I said, that unknown may just be an application that hasn't been configured properly, but it could also be the next generation of ransomware making its way into your business. So this is what we talk about at Juniper when we're talking about our software-defined networking vision, software-defined secure networks. This is about coming together of technologies to better benefit the business. It's really about leveraging the intelligence that you have. You've got so much information and intelligence built into your network, right around your environment, with other organizations around the globe using cloud-based threat intelligence. Why not leverage it? I mean, think about it. Every single piece of data that you have traverses the network at some point, whether that's a spreadsheet, an email, a Word document, at the same time, a piece of ransomware, the latest 0-day, a phishing attack. All of those are going on the network. So the best thing to do is to embed security to the network and leverage that intelligence so that you're able to protect right the way across before threats are able to get a handle on the inside. So what we have here really boils down to these points. The first thing, the most accurate threat detection that you can have. Being able in near real time to see a threat as it comes in, to be able to perform identification against it, understand what the risk is, and report that back with one-touch mitigation available in many cases. So press a button and you can actually deal with that situation. Global policy management. When I create a policy, it can be effective on all of my devices at once, whether that's a physical firewall, whether that's a virtual firewall, a containerized firewall, a physical switch or a virtual switch. All of these, I can have policy effective on those immediately using our policy enforcer and our security director to make that happen. But at the same time, incredibly granular enforcement. We know that not every single device wants exactly the same configuration. In some cases, they will have very specific configurations. So you can layer things so that as you move down, the policies become much more granular to specific devices with specific functions. And then finally, as I just talked about with the one-touch mitigation, automated threat remediation, allowing the network intelligence to be fed back in, and then allowing security director and policy enforcer to use the information that they see from the Juniper analytics to say, okay, analytics has reported I've got a problem here. This is what the problem looks like. This is how this can be dealt with. And then to create an automated action based on rules, which can be fed back into the network faster than a human would be able to respond and make this happen. Bringing all this together, what it gives us is an intelligent, automated, and secure network platform. And this is what we talk about at Juniper when we talk about the Juniper software-defined and secure network. Single detection and enforcement domain right across your network. Integrated intelligence from right over the internet, from your business, from businesses around the world. This is how you can secure your data and make sure you're safe. Secure your brand and make sure you remain in business, and keep your customers happy and confident that you're the right people to be with. And with that, I hope that you found something interesting there. I hope that you can see that IoT is definitely going to be very important in the future, and the need to protect and secure IoT is going to be even more important. So thank you very much for listening.